All right, now a stationary policy, which sometimes in the literature is referred to as a universal plan, is actually what we talked about in the context of MDPs. So mapping from states to actions. And this is a very powerful sort of thing because it can handle stochasticity really well. Every time you take a transition, you go back to your table, you go back to your policy to say, all right, here's the state that I ended up in. What's the right thing to do from here? It is kind of hard to convey these to people, though. Do you see why that might be?
Yeah. Well, so one way it might be is because I will claim that a stationary policy or universal plan is just a conditional plan where you have an if at every single possible state.
That's true, but it's actually a little bit more constrained than that, which is it's the same if at every possible state.
Right.
So no matter where you came from, no matter what you were in the middle of doing, once you discover where you are, that's going to determine what your next step's going to be.
Right. And that's a lot of if statements.
It's a lot of if statements. Yeah, and right. So if you try to convey it, you have to actually tell someone what all those if statements are. It's sort of like if I want to give you directions to my house, a plan might say, go left, go right, go left, go down until you get to Maple Street, make a right. A conditional plan might say something like, go to the highway. If you get there and it's crowded, then go these back roads, otherwise go on the highway. And and a policy would say something like, for every location in my neighborhood, here's the direction that you should turn.
Mm,
And yeah, and that's going to be very large.
right. And in some ways, not very useful.
Well, define useful, right? So it's
Well,
very useful in the sense that it is very powerful and it can handle any kind of stochasticity. And there's always an optimal stationary policy for any MDP. So
okay.
that's a really nice property. You never have to look beyond the stationary policies to find something that's optimal.
Okay. So then I take back what I said. It's not that it's not useful. It's that, in fact, it's very useful. It's that it's not very compact, or as you have up there, it's very large. So
Very large.
you have to say a lot.
Yeah, yeah. So that's exactly right. All right.
Hmm.
But now for the learning algorithm, it could mean that it has to learn a lot. It has to discover what a reasonable thing to do is in every one of its possible states. So that could actually make the learning problem difficult. But anyway, I just wanted to at least raise this issue. We're going to be focused almost entirely on these stationary policies because they do allow for the possibility of expressing an optimal behavior.
Cool.